Assalamualaikum and a very good day to all the panels. My name is Mohamad Fahmi bin Fadzil and the title of my final year project is Design and Simulation of Quality Inspection Line. Firstly, we go to the abstract of this project. This quality inspection line has three levels of inspection, which are: the first level will inspect on the color selection of the bottom part of the product. The second level will inspect on the color combination of top and bottom parts of the product, and the third level will inspect on the top and bottom part assembly. This Karakuri system will stimulate the movement of the product from a first level until the third level in this quality inspection line by relying on the gravity and basic mechanism without using any electrical and hydraulic equipment. But the inspection process still will include with the electrical equipment like sensors, actuators, and analyzer in order to take the challenge of Industrial 4.0. There are two software used for this project, which are Latia software that used for all the design process of the quality inspection line, and the another software is Blender, which is used for the stimulate the quality inspection line process. Now we go to the introduction. Research background. Quality inspection line will assist a company to fix any potential issues or defect of a product to ensure that just a good quality product will be delivered to the customer in order to attain high levels of customer satisfaction. If the customer is satisfied with their product and they always maintain the product quality, they surely will not lose any substantial market share to their competitors. Nowadays, many companies try to reduce the manufacturing cost, and some of the companies are start to apply Karakuri into the system, which is a system that cheaper if compared with the computer system. This is due to the maintaining a Karakuri system is easier and does not need a massive cost to fix it. Any problem or issue in the Karakuri system also easy to recognize. However, for the computer system, the company need to hire an electrician or a programmer that surely will increase the manufacturing cost. Next is problem statement. There are a few problems that I have found that can relate to this project. Mostly high inspection time that normally due to the human inspection because of the process of the inspection is slower if compared to the automatic inspection system. This will surely affect on the production time and the number of product produced. Next, high operating costs. Several companies try to reduce the operating costs in order to remain competitive. This problem can be prevented by replacing an automatic operating system that uses electrical equipment and electrical power supply to a system that fully relies on natural forces like Karakuri system. And lastly, the problem that found is poor quality control system leads to the low quality of quality product. A poor quality control system surely unable to detect any defects or problems in the product. As a result, many low quality products will be delivered to the customer, and this will be effect on the customer satisfaction. From all the problem statements that we mentioned before, there are several objectives that need to be achieved in this project. First is to design an automatic quality inspection system for the Smart Mari factory line with Latia software. Next is to simulate the process of automatic inspection system for this quality inspection line. Finally is to develop a quality inspection system that based on the Karakuri system. The final part of the introduction is scope of this project. This project will focus on designing and simulating the Karakuri Transportation Quality Inspection Station as the replacement of electrical and electronic conveyor system for the smart Karakuri line of a stationaries and phone holder surveillance. Now we go on to the methodology of this project. DMADV method is applied in developing the methodology part. What is DMADV? DMADV is the 5-step used to develop the methodology, which is define, measure, analyze, design, and verify. The first step is define. The main issue of this final year project is how to create a design for the quality inspection line. It's an automatic and low-cost operating system. Thus, all of the project's problems were stated, all of the project goals were specified, and the target process were outlined for this defined process. And all of this will be shown as in this table below. The performance of this quality inspection line should need to be relying on the Karakuri Kaizen. The material of the product used is aluminum profile. The cost of the material is need to be 450 ringgit, and the size of the quality inspection line is 1000 mm times 800 mm times 186 mm. The maintenance and adjustable is easy to maintain, and the safety of this quality inspection line is anti-corrosion. Next, we go to the second phase, which is a measure phase. This phase will study and understand the process sequencing and the functions of an automation system that need to be applied in this quality inspection line. For a better understanding on the karakuri system, further study has been made. So, a site visit and a meeting has been arranged with Successful Supplies Manufacturing Sdn Bhd, which is a company that actively involving in karakuri product marketing. This meeting provides information about the karakuri mechanism, and the company provides samples of the karakuri mechanism that have been deployed in actual industries to demonstrate how they operate. This surely helped me in designing the quality inspection line. Then we go to the third phase, which is the analysis phase. The quality inspection system process is analyzed in this analysis phase. For a better understanding of the function sequence and the process flow of this quality inspection system, an illustration figure and a system flowchart was generated. The process of the quality inspection system for all of the levels in this quality inspection line is the same and closely related to each other, but it only differs on the criteria that need to be inspected for every levels. Now we go on the first level. As we can see, the bottom part will arrive and stopper will stop the product for the inspection process. If the product color does not match with the order by the customer, the pusher on the side of the line will push the product into the NG box. However, if the product meets all the criteria needed, the pusher will push the stopper and allow the product pass to the next session. As we can see on the flowchart here, the first level will check on the color checking for the bottom part of the product. Now we go on to the second level. The mechanism of the second level is still the same with the first level. The combination part of upper and bottom part of the product will arrive and stop by the stopper, and on the side, pusher will push the product if the product is rejected, and the pusher on the bottom will push the stopper to allow the product pass to the next station if the product meet all the requirements. As we can see, the flowchart for the first level and second level is still the same. They will do a color checking for the inspection process. Now we go on to the third level of the quality inspection line. The mechanism for this third level is still the same with the first and second level of the quality inspection line. However, it will be different on the process of the inspection, which is this level will check on the assembly of the bottom part and upper part of the products. Then we go to the design phase. There are three parts that have been designed, which are the design of the stopper, design of the pusher, and the design of the NG box. The design for the stopper is the result of a combination of several karakuri equipment supplied by the Successful Supplies Manufacturing Sdn Bhd. The stopper is designed to hold the product while undergoing the inspection process in this quality inspection line. This design next we go to the design of the pusher. The design is selected because it is simple design and easy to install. The first pusher works to push a reject product into an NG box, while another pusher works to move the stopper. Next, we go to the NG box. The NG box is also known as the rejection box, which is a box that is designed to collect all the rejection product. This box is designed to hold 9 to 10 complete combination products that have been rejected, and all these boxes will be placed at the right side of the line, and any product that have not met all the required criteria will be rejected by the pusher directly into this box. Finally, we go to the last phase, which is the verify phase. In this phase, a dynamic analysis will be done. This analysis is divided into two parts, namely pusher dynamic analysis and product rejection dynamic analysis. The main theory utilized for the dynamic analysis is Newton's second law of motion. The formula is used to investigate the effects of numerous forces on the movement of the product. Next, the equation of motion are another type of formula that is employed. There are four essential formulas used in this equation of motion, as shown as in the figure. These formulas are applied to analyze the kinematic motion of the product when it rejects into the NG box. These formulas also analyze the kinematic motion of the stopper when it has been pushed by the pusher, And these calculations are also used to compute the inspection system cycle time. For the result and discussion of this report, there are several results that will be overviewed. First is on the overall design of the quality inspection line. All the parts that have been designed before, which are the stopper, the pusher, and the NG box, will be assembled into a line that has been designed by another final year project student. The location of all the parts that have been designed are same for all the levels in this quality inspection line. As we can see on the figure, there are two pushers used in a single quality inspection line. First is on the left side of the line, which is function to push a rejected product into the NG box, and another pusher is at the bottom part of the stopper, which is function to move the stopper. And the stopper, the ebenezer, will be attached in the middle of the line, and the NG box design will be attached on the right side of the line to collect all the rejected products. As I said before, all the parts location are same for all the levels, and this is the second level of the quality inspection line. And this is the third level design of the quality inspection line. Next, the another two results that will be overviewed are the cycle time and the pusher mechanism. These both results are related with each other. By using all the formula that have listed in the methodology part at the verified phase above, the pusher force, the velocity, and the total cycle time for the product reject process and the pusher movement are calculated. The results are shown in the table. For the pusher mechanism analysis, for product reject, we can conclude that the force of the pusher to push a reject product into the NG box is 0.47 Newton. And for the pusher movement, the force need for the pusher to push the stopper is 2.8 Newton. Next, we go to the costing, which is another result that will be overviewed in this result and discussion part. The estimated cost for complete the fabrication process of the quality inspection line is shown as the table below. The price includes all the costs of the materials and equipment used. As we can see, the estimated total cost is around 790 ringgit and 42 cents, and the larger cost is for the aluminum profile, which is 450 ringgit. The second highest cost for this fabrication process is the price of the drill machine, which is 219 ringgit and 48 cents. Now we go to the simulation process, which is the final result that will be overviewed in this result and discussion. In this simulation, it will show on how the inspection process if a customer order a full red color of a phone holder, Mari phone holder. As you can see from the video, just a red color part will be allowed to pass to the next station. If the product is meet all the criteria, the pusher at the bottom of the stopper will push the stopper, and if the product is reject, the pusher at the side will push the rejected product into the NG box. This is the simulation process for the quality inspection line on the second level. So we can see the first product is reject because the color combination for the upper part and the bottom part doesn't meet the color requirement. However, the second product is allowed to move to the next session because it's meet all the color requirements. And this is the simulation for the final phase of the quality inspection line, which is the third level. The mechanism is still the same with the first level and second level. However, it will inspect on the assembly requirement, and as we can see, just the first product is meet all the assembly requirement, and the second level and the second product is reject because it doesn't meet the assembly requirement. Now we go to the final part of this project report. As a conclusion, I can see that all the objectives is achieved. This is because from the result and discussion, we can see the quality inspection line is successfully separated into three sections. The mechanism also successfully to be designed because it's same for every section but different on the product characteristic. The overall design for the quality inspection system also successfully designed by the Kata software. The additional design ideas like stopper and pusher also successfully designed by the Kata software, and the main idea of this quality inspection line is to apply Karakuri Kaizen into the system also has been done. Thank you to all the panels. That's all from me. And if any misunderstanding or problems, you can contact me via my email or phone number. So, thank you.